Hello everyone, I am Mohammad Khalid and welcome to my YouTube channel Physic-so-Mathematica Techno-Computa. In this video I am going to solve the coding ninja problem, and it's a problem of the day problem and it's medium type problem. So the problem goes like this. Levi Ackermann has two arrays A and B consisting of n integers each, which means Levi has two arrays A and B, and in both the arrays there are n elements and element type is integers. He wants to divide these two arrays in two parts. So he wants to divide the array, both array A and B, into two parts such that the sum of all the elements in the first part is equal to sum of elements in the second part. He wants to divide in such a way that the division at which occurs from that left side and then from that position to the right side, both, if we sum up, both the sides should be equal. And not only in one array, in both the arrays it should be follow, which means basically if we divide the array two arrays, then there will be basically four parts and all the four parts have to be equal, and the index k where the splitting is done must be same in both arrays. So basically where we will be dividing, so that position in both arrays should be same, that they are saying. So, and in simple terms, if we split an array at index k, then a of 0, 1 to k will be the left part, which means left position, left side part, and a of k plus 1 to a of n minus 1 will be the right side part. In the same way from b also occurs. In the same way b side also, from b0 to bk will be the left side part, and b of k plus 1 to b of n minus 1 will be the right side part, and this all four parts have to be the same. So if it is same, then we'll say that okay, there is index k in that array, and we have to find such index k's. Basically we have to not return the k positions, index positions. We have to simply return how many such indexes are there in the given array. So example the given is array is 2 4 5 1. So let me take this is the array A, and elements are 2 4 5 1, and array B as 3 3 10 minus 4, array B as 3 3 10 and minus 4. Since as you can see there are 4 elements, so n has to be 4, so which is basically given here. So now if let's say our k position is here, k in a sense like the index position, so if we divide in such a this way, so the left side sum will be 2 and then right side sum will be 4 plus 5 plus 1, which is basically 10. So these two sums are not equal, so this position is not required in our case. So we have to, let's say, take position here now. Since we took k position as here, now we have to make partition. So these two sums, 2 plus 4 is 6, and then here 5 plus 1 is 6. So these two sums are equal. Now we have to check in this also, like 3 plus 3 is 6 and 10 minus 4 is 6. So as you can see, all the four parts, these four parts are same, they are giving the same sum. So this position is giving as required in the question. So we have to take one variable known as count. So we have to increase count to 1, which means we have found one position. Now let's try to find one more position, like do we have more of such position where all the four sums are equal. So let me try to find that. Now let's say we took here as k. So now if we take here, we have to make partition here in this way. Now if you sum up 2 plus 4 plus 5, which comes out to be 11 and then 1, so basically these two are not equal, so we have to not take such positions. If we take here this we can't take here. One more if we take here, because if you take here the partition will be in this way. So this 4 will be in the left side and there will be no element in the right side part. No elements are there. So since there are no elements, so such partition is not allowed. So I think you got the question. Now we'll try to find the solution for this. The solution is very easy. What we'll do is we'll first take 4 variables. Sum, we'll take sum 1. Sum 1 represents sum of array A, let's say, or you can take sum A. Also we can take, or I'll be taking here as sum A only. Sum A, and then this left part I'll be taking it as I, sum of AI. Initially this sum I'll be putting it as 0, and then sum of A, and the right side part will be the sum of AJ, let's say. So this sum will be the whole sum array. We will be first running the loop where we will be finding the sum of all elements of the array, and we'll be putting this variable. So this will be the sum of J part. So in the same way we could will take for sum B also, sum B and ith part, basically left side part. So this will be taking first as 0, and then sum B right side part, which is J basically. So this will be the entire sum of the array. So if we take in this case 16 minus 4 is 12, and in this case if we take, it is like 6 plus 4 and 12, same thing, 12. So first we'll do this step, and then we'll run a loop which runs from this position to this position. So one by one what we will be doing is we'll be adding one element in this particular sum. So arrays this position element will be adding to this particular variable, and then this particular sum, this particular element will be removing from this. So basically what it depicts is taking the element 2, and then rest all element are there in this variable, and then we'll try to equate this 2. In the same way for B also we'll be doing. If our position is here, then this element will be storing in this particular variable, sum B of I, and then we'll be removing from this element, from this variable, this element. So it's like this element is stored in this variable, and these 3 are stored in this variable. So in this way we'll check if, and we'll check one more thing, like if these 2 are equal, and also if these 2 are equal. So if you want to compare 4 variables are equal or no, so you can make only 3 comparisons for that. Like if we check for these 2 equal, so let's say we have this only, we are taking it as A, B, C, D. So in order to check if these 4 variables are all equal or no, so first we'll equate these 2. Okay, we'll find that if these both are equal, and then we'll equate these 2, which means these 2 will be equal. And then since these are equal and these are equal, we'll compare only this, either this or this will compare. So if you compare these 2, then we'll conclude that all the 3 are equal. So let me write this code. First we need to find the length of the array, since they are not given here, only the vectors they have given, A and B. So int length equals to A dot size. This will give the length of the array, since both the arrays are of equal lengths. So if you find one length, it's good enough to solve the problem. Next we are taking variable int sum A I, which means left part will be putting it as 0, and sum A right side part, this also will take first 0. In the next we will find the total sum of the array, and then we'll put it here. So next we have to take sum B of I equals to 0, which means sum of all the left elements of the array B. Next we are taking B of J, which is also 0, and then we'll run a loop. from 0 to length minus 1 we are running the loop. And so next we'll take one by one elements and then we'll be adding it to the variables. So a of I, we'll take all the a of I elements, we'll put to one by one, we'll take and we'll put to the variable j, sum j. And the same way for b also. So now in our variable, in sum a of I we have 0 and sum a of j we have all the sum elements from after this loop. And now we'll run a loop from same I0 to I length of length minus 1. So basically why we're running from length from 0 to length minus 2 is as I said, like if you take all the elements left side, then there will be no elements on the right side. So this is not the correct partition. So next will be increasing, and now what we're doing is in the sum a, which is left part, basically I means left part, in that we'll be adding a of I. Okay, and then since we added the first element, let's say, so we have to remove from j part, basically right part we have to remove. So a of I, so basically it's correct. So basically we have taken all the elements sum in this a of j, and then in a was 0, so first element we added and then first element we have removing from here. So this makes the perfect partition. So in the same way for b also we have to do sum of sum b of I. In this we have to add b of I, and then sum b of j we have to remove from here b of I. And now since partition is done perfectly, now we have to check if all the 4 partitions are correct or not. So for that we have to check if sum ai equals to sum aj, which means first array is left and right part, we are checking if it is correct, and only this is not the condition, we have to check part b also, left and right part should be equal. Sum b of I equals to sum b of j. So this gives the independent sum of the element, sum of the arrays, like left and right part of the array A are equal, and this will give the left and right part of the array B are equal. Now we have to check if these equal parts are in between equal, which means like left part of array A and left part of array B both have to be equal. So we have to take sum of A of I equals to sum of B of I. Okay, so if this is the case, which means we have found one position in an array where this condition satisfies, we have to simply increase the count. Let's say first we have to take one variable count, and this should be initialized to 0. So which means one position we have found in the array. This is, so in the similar way it goes to second element, third element, so until length minus 2, and it checks if this element if this condition is true. If it's true, then it will increase the count. So lastly we have to return the count. Now let me run the code. All test case passed. Now let me submit the code. Yeah, so all the test case has been passed. So thank you guys for watching my video.